Hey guys, welcome to a what you need to know video for tomorrow's graphs internal. And once again, I know this video is very late, but I haven't had time over the past few days to make a video, so I apologize for that, okay? Hopefully you can get the most out of this video, and I hope it's not too late for you guys. Alright, so what you need to know, we'll start off with what you need to know and how to figure out equations, okay? So equations of graphs is what we're going to start off with. Equations of graphs, okay, and then we'll start off with hyperbola. Okay, so the basic equation of a hyperbola is y equals to k divided by x, okay? But for your exam, okay, so most of the exam questions you're gonna get, so the internal exam, the hyperbola is probably gonna have been shifted a specific amount of units left or right, and a certain number of units up or down, okay? So then we have to find out the transformed equation of the hyperbola, okay, which is y equals to k divided by x minus b plus c. Okay, so b is how much has been shifted right and left, okay? So if I shifted right, it's positive, okay? So it becomes x minus whatever amount I shifted right. And if I shifted left, okay, it becomes x minus whatever I shifted left. So it becomes x plus the amount of units I shifted it left. And c, okay, c is how much I shifted up or down, okay? If I shifted up, then c is positive, okay? Shifting it up, c increases. If I shift the graph down, then c obviously decreases, okay? Okay, so in terms of finding the equation for hyperbola, okay, the standard way you should probably approach it is estimating one asymptote, okay? So you should estimate one. So it doesn't really matter which asymptote you estimate, okay? So it could be the vertical asymptote or the horizontal asymptote. And then you'll substitute substitute 2 points in the hyperbola, okay? You substitute 2 points in the hyperbola. You use simultaneous equations to find the value of the other asymptote, okay? So you're gonna estimate one asymptote, okay, and then you're going to use simultaneous equations to find the other asymptote, and once you find the other asymptote, you can just you substitute the point in to find for k, which is really easy, okay? So I'll give you an example, okay? So an example maybe for example, we'll just say graph we'll say a graph somewhere along that's not very good. Graph hyperbola looking something like this. Jesus. Sorry guys. Okay, that's a bit better. Okay, so if for example, we have a hyperbola going somewhere like this, right? Okay, a shape like this, okay? So, well, obviously we're going to, for example, we're going to estimate one asymptote, okay? So we know the transform equation for a hyperbola y equals to k divided by x minus b plus c. Okay, so looking at this graph, okay? Looking at the which asymptote would be easier to estimate, okay? So if we look at the vertical asymptote, okay, so obviously you can see the vertical asymptote is pretty obvious that it's going to be it's pretty obvious that it looks like it's going to be c equals to no, not c, x equals to 1, right? But if we looking down onto the horizontal asymptote, oh shoot, if you look down on the horizontal asymptote, it's not really clear exactly. If we continue the hyperbola, it doesn't look very clear as to what exactly the asymptote is going to be. So in this situation, I think the best way to approach it is to substitute your vertical asymptote as x equals to 1, okay? So that's this, oh, I did it again. Okay, so that's this asymptote right here, okay? So if we just say, for example, y equals to k divided by x. Okay, so we're going to substitute the vertical asymptote. Okay, so we should communicate to our marker first. Okay, so we should say I will assume the vertical asymptote is x equals to x equals to 1, okay, so y equals to k divided by x minus 1 plus c. So now we're going to substitute 2 points into the equation, okay, so we'll say that this point right here, that's 3, negative 3, and we'll say that this point here, that's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 5, negative 6, okay. So those are the 2 points we're going to substitute, okay. So we're going to say negative 3 equals to k divided by 3 minus 1, 3 minus, sorry, not 1, 3 minus b, no, 3 minus, it is 3 minus 1, sorry, what am I doing? 3 minus 1 plus c, okay, and we're also going to say negative 6 equals to k divided by 5 minus 1 plus c, okay, so if we simplify this, we'll say negative 3 equals to k divided by 2 plus c, and negative 6 equals to k divided by 4 plus c. Okay, so the next thing we should probably do is we should probably make see the equation, see the subject of the formula, okay, so we'll say that k divided by 2, move the minus 3 to the other side, becomes positive 3, so k divided by 2 plus 3, and then you move the plus c to the other side, becomes minus c, okay, so you should get this here, so we get, so for the other equation, we get k divided by 4 plus 6 equals to negative c. Because they're both equal to negative c here, we'll say that k divided by 2 plus 3 equals to k divided by 4 plus 6, okay? And now we can say we'll move the plus 3 to the other side, so we'll say k divided by 2 equals to k divided by 4 plus 3, okay? And then we'll say k divided by 2 equals to k divided by 4 plus 3 over 1. K divided by 2 equals to k divided by 2 equals to k plus 12 divided by 4. And now we're going to use cross multiplication, so we say 4k equals to 2k 2 times of k plus 12, 4k equals to 2k plus 24. Therefore we get 2. Sorry if it's a bit unclear, but you should still be able to make it out. So 2k equals to 24, k equals to 12. Okay. So now we're gonna say we found out what k is. K equals to 12. So y equals to 12 divided by x minus 1 plus c. Now we just need to find the c value, okay? That's pretty easy, okay? So we just substitute, put, for example, this point in, okay? So we'll say negative 3 equals to 12 divided by 2 plus c. Negative 3 equals to 12 divided by 2 is 6 plus c. Obviously, c must be negative 9. Okay, so now we can write out a new equation, y equals to 12 divided by x minus 1 minus 9, okay? And that should be your final equation here, okay? Y equals to 12 divided by x minus 1 minus 9, okay? And that's solved by using the simultaneous equations. Okay, so basically you're just estimating one of the asymptotes, okay, and then you'll solve using simultaneous equations, okay? That's the safest way to do the hyperbola, okay? If you substitute both asymptotes, there's a chance that your hyperbola won't be in the desired shape, okay? So the hyperbola might not pass through the points that you want it to pass through, and in terms of getting the grade you want, it'll get you a mark down, okay? So you will be penalized if your modeled graph does not pass through the correct points, okay? So it's very important that your modeled graph pass through the correct points, okay? So a tip during the exam, okay? I know Miss has already said this, okay? But an important tip during the exam is always after you find the equation of a graph, just put it into your graphics calculator to see the approximate shape of the graph, okay? It doesn't have to be perfect, okay? But it can't be too much difference, okay? So I'm not saying your graph has to be perfect. I'm saying that your graph has to be similar to what the requirements are on the exam, okay? And you can check that using your graphics calculator. Okay, so basically, for the hyperbola, how to find the equation? You substitute, you estimate one asymptote, and then you solve using simultaneous equations. Okay, so that's basically the safest way to do the hyperbola. However, if you're only given 1 point, okay, if you're only given, so right here I have 2 points of the hyperbola, right? So that's this point here and this point here. However, if you only get 1 point in the hyperbola, then you could estimate both asymptotes, and then you'll substitute that 1 point to find the k value, okay? So that's only if you have only 1 point you can go off. But if you have 2 points that the hyperbola clearly goes through, it is very important that you use simultaneous equations, okay? So if there's only 1 point you can see, then it's fine to estimate both asymptotes and then substitute that point to find your k value. But if there's given 2 points on the graph, okay, 2 clear points, you have to use a simultaneous equation to solve, okay? Or else there's a very low chance your hyperbola will pass through both of these points if you estimate both of the asymptotes, okay? So that's basically it for the hyperbola, okay? I'm gonna moving on to the exponential next. Sorry, should have. Sorry guys, just skip through the video so you don't waste any time. Skip through the video right now so you don't waste any time watching me rub stuff out, because that's not very useful to your learning. Okay, so the exponential, okay. Oh wait, never mind, there's still some stuff here. Alright, so we have our exponential graph, yes? Okay, so our exponential, the basic equation of our exponential is y equals to a to the power of x, okay? That's our basic exponential. Our shifted exponential will be y equals to a to the power of x minus b plus c. Once again, b is how much has been shifted right or left, and c is how much has been shifted up and down, okay? Or we can also say that y equals to k times of a to the power of x. Okay, so depending on what type of exponential they give you, you can use any both of these equations that will work out just fine. Okay, all right. So how do we work out the equation for the exponential? Okay, so to work out the equation of the exponential, okay, so first thing you have to find is the asymptote, okay? So you have to so you got looking at your exam paper, looking at the exponential, you'll see what does the exponential get closer and closer to but never actually reach, okay? So what is the asymptote of the graph? If you find that the asymptote is 0, so the exponential gets closer and closer to 0, okay? If you find the asymptote is 0, then you can use y equals to k times of a to the power of x. However, if your asymptote isn't 0, so for example your asymptote gets closer and closer to -5 or gets closer and closer to -8, then you cannot use y equals to k times a to the power of x, and you have to use this equation. So y equals to a to the power of x minus b plus c, okay? So so it's really depending on the situation of which equation you would use, okay? So I'll give an example for both, okay? We'll start off with y equals to a to the power of x minus b plus c. So how would you approach this type of question given an exponential, okay? So we're just gonna draw an exponential. Just forgive my bad drawing, but here we go. Yeah, I guess that kind of works. Okay, so for this well, actually that doesn't work. That asymptote is 0. Try another one. Yeah, okay. So for example, we have this exponential right here, okay? So as you can see, the asymptote, okay, it seems to get closer and closer and closer to negative 2, but it never actually reaches negative 2, okay? So you know your asymptote must be y equals to 2, okay? So so basically, so you can already write down your equation, like a little bit of your equation. So you say y equals to a to the power of x minus b plus, not plus, not minus 2, it's positive 2. What am I even doing? It's 2. So a to the power of x minus b plus 2, okay? So that's your, so that's substituting your asymptote into your equation, okay? So now we need any 2 points to find a and b, okay? So for example, we'll use this point here, we'll use this point here, okay? So that's, no, so this is negative 4, negative 4, 9, okay? And this, in this point here, that's negative 2, negative 2, 12, okay? So we just substitute both of these points into the equation, okay? And we'll find our values of a and b, okay? So basically, if we substitute negative 4, 9, we'll get 9 equals to a to the power of negative 4 minus b plus 2. So therefore, if we move the plus 2 to the other side, we'll get 7 equals to a to the power of negative 4 minus b, right? And if we substitute negative 2, 12, okay, we'll substitute negative 2, negative 2, what am I doing? Substitute, yeah, 12, this is 12, not negative 2. So 12 equals to a to the power of negative 2 minus b plus 2. We'll move the plus 2 to the other side, we'll say 10 equals to a to the power of negative 2 minus b. Alright, so as you can see, we're in it's a bit confusing right now, okay? So we have 2 unknown values and 2 equations, okay? So we're going to be using the log method to find out both a and b values, okay? Okay, so we have one equation, 7 equals to a to the power of negative 4 minus b, and we also have 10 equals to a to the power of negative 2 minus b. Okay, so you know in algebra, you take the logs of both sides, okay? You'll say take the logs of both sides, so log of 7 equals to, you bring the power down, you log of the base, okay? So negative 4 minus b log a, yes? And we also have log 10 equals to, take the power down, log of a, so negative 2 minus b log of a. So now basically we just solve using any how you would normally solve simultaneous equations. So we're going to combine these 2 equations and we're going to find our value for a, basically. So so basically if we say log 10 minus log 7 equals to, so that's negative 2 minus b log a minus negative 4 minus b log a. Is that right? Yep. Happy? Okay, so you know in algebra, right? For example, you have 2x plus 3x. And that gives you 5x. We all know that, right? And the only reason you can add the 2 and the 3, you can add the 2 and the 3 because the x is the same, okay? So for example, I have 5xy plus 6xy, that equals to 11xy. Why can you add the 5 and the 6? That's because xy is both the same, right? But for example, I have 5xy plus 5x. Does that give you 10xy? No, it doesn't give you 10xy because the xy and the x, they're different, okay? So basically that's called like terms, okay? Adding and subtracting like terms, okay? So as you can see here, both of these is log a and log a here. So basically we can just do negative 2 minus b minus negative 4 minus b, okay? Log of a, okay? So it basically just becomes normal algebra. So just imagine right now that log of a is just x, okay? And that will make it easier, okay? So just imagine they're both log a, so that means we can just subtract, okay? So log 10 of log 7, okay, that should give us log of 10 divided by 7. So you know in algebra, again, you divide powers, okay? Not divide powers. You divide, okay, when you take logs. So for example, log 4 minus log 2 equals to log 2. 4 divided by 2, okay? That was not a good example because 4 minus 2 is also 2. Wow. So I'll give you another example. Log 8 minus log 2 equals to log 4. Okay, so 8 divided by 2, okay? So log 10 minus log 7 is log 10 divided by 7, okay? And that equals to negative 2 minus b log a. Minus 4, that becomes plus 4. Negative b, that becomes plus b log a. So therefore, we'll keep that as 10 divided by 7, that equals to negative 2 plus 4, that's 2. Negative b plus b, gone. Just like that, just gone. And then we have 2 log a, okay? And now we just take the logs away. So basically, I like to call it unlogging both sides, okay? I know that's not what you actually call it, but just a funny nickname, I guess. Unlocking both sides. So basically, if we unlock both sides, we just say 10 divided by 7 equals 2. You move the power back, okay? So that's the power and that's the base, okay? So we say a to the power of 2. So therefore, a equals the square root of 10 over 7. And we should plug that into our calculator. Okay, let's try this again. Sorry guys, I should have had the calculator ready with me, but my unpreparedness is not very good. Okay, so if we say square root of 10 divided by 7. Wait, just let me 10 divided by 7. Square root of, okay, so you get 1.19. A equals to 1.195. Okay. So basically now we have to just find the b value, okay? That's also pretty straightforward, okay? Because we have the a value, we just find our b value, okay? So now we can rewrite our equation. We'll say that y equals to what was that? 1.195 to the power of x minus b plus 2. And if we substitute, get one of these equations, so let's say get this equation here. So we say 7 equals to 1.195 to negative 4 negative b. So for now, we'll just call this x, okay? So we'll say negative 4 minus b equals to x, okay? So we'll say 7 equals to 1.195 to the power of x. Log both sides, so log 7 equals to x log of 1.195, and then we have log 7 divided by log 1.195. So log 7 divided by log of, and that should give us and that gives us x equals to 10.911. Okay, so remember we made negative 4 minus b equal to x, and now we have x, right? So now we have to say x equals to negative 4 minus b. 10.911 equals to negative 4 minus b. You move the negative 4 to the other side, it becomes 14.911 equals to negative b. Divide both sides by negative 1, so negative 14.911 equals to b. Okay, so now we have our b value. It's negative 14.911. Substitute that back into our equation. Okay, that equals to y equals to 1.195 x. Okay, so minus b, right? So minus, and then b is negative. So double negative makes a positive. Don't forget that. Double negative makes a positive. So it becomes plus 14.911. And then whole thing plus 2. And that's your equation for your graph, okay, for your exponential graph, okay. And that's by using the y equals to a to the power of x minus b plus c equation, okay. Just let me double check if my graph is actually right at all. to the power of 1.159 x. Sorry, what am I doing? So x is 4, so 10 should give us 9, yes. Yeah, that gives us. Yeah, that's right. Okay, so that's the correct equation. Okay, I just checked with my calculator. This is the correct equation for our exponential. Okay, and I know it's a pretty tough process. Okay, but if necessary, it could be helpful in your exam. Okay, so now we have to be moving on to the exponentials with the y equals to k times a to the power of x, which is a lot easier. Okay, but for now I'm going to cut the video off here for now, just in case my screen recorder cuts off, because my screen recorder sometimes cuts off when the video gets too long, and if the video gets cut off, then I'll actually lose the entire video. It's happened a few times, but just to keep things safe, I like to cut the video off a bit earlier so that doesn't happen. Okay, sorry about that, but I guess you can just click on the next video and we should be continuing with our graphs. Thank you for watching.